So it's a point that's in the middle. And we create two congruent segments when we have a midpoint. So we've talked about, so you already have that written, hopefully. We've talked about what happens if we do have a midpoint on a line segment. We know that this side should be the same as this side, right? And you did that all for your homework, and hopefully you guys felt pretty adequate doing the homework. So now what's going to happen is we're going to take our line segment and we're going to put it on a coordinate plane, okay, an XY axis, a graph, and we're going to have to use the midpoint formula to find the midpoint. So go ahead and get this jotted down in that formula box. So we're going to use a capital M to stand for midpoint. And the midpoint formula is a lot more simpler than it might appear to be. But if I needed to find the middle of 2 points, all I'm going to do is I'm going to take my two coordinates, add them together, and divide it by 2. Like, for example, what number is exactly between 0 and 10? 5. How did you get that? Yeah, 0 plus 10 is 10, divided by 2 is 5. What number is exactly between 1 and 5? 3, right? Because if we do 1 plus 5, that is 6. Cut that in half, gets you to 3, right? So all we're going to do is we're going to take one of our x coordinates, add to it a second x coordinate. So that's what those subscripts mean. X of 1 plus x of 2. That just is identifying point 1, point 2. You'll divide it by 2. Then you'll do the same thing for the y coordinate. Can everybody identify the x and the y coordinate in an ordered pair? The x is the first number, the y is the second number, right? Okay, so let's use this midpoint formula down here on this example down here on the bottom. Is this your last one on the bottom there? Yeah. All right, so find the coordinates of the midpoint of points R and S. So if it helps you, do some labeling. We'll call this point 1. We'll call S point 2. So I'm going to put an x sub 1 and a y sub 1 above my x coordinate of the R and my y coordinate of the S. I'm going to do the same thing for S, which I'm going to call point 2. So x sub 2, y sub 2. So now if you have that formula in front of you, plug everything in. So my midpoint is equal to, I'm going to put a parentheses, my x sub 1, which is 1, plus my x sub 2, which is 4, divided by 2, comma. Now I'm going to do the same thing for my y's. Y sub 1, which is negative 3, plus y sub 2, which is 2, cut that in half. Now we just need to do some mental math. 1 plus 4 is 5. That's half of 5. 2.5. Good. Negative 3 plus 2 is negative 1. Divided by 2 is negative 1/2. So the ordered pair, 2.5 comma negative 0.5, would be where the middle of that line segment would be. Okay. Now, just for more clarification, I'm going to graph this. You're not going to have to do this, but I just want you guys to visualize what's actually happening. So if you make a quick rough XY axis off to the side, plot point 1, negative 3 for R. Again, you're not going to have to do that. That's going to be your answer. I just want you to visualize what is happening here. S is at 4, 2, so go to the right 4, up 2, and put point S. As best as you can, try to make a straight line through those. connect them. So now locate point 2.5, negative 0.5. Where would that be? Well, 2.5 down a half. Does it look like it's falling mostly on your line? It may not be exact because we didn't do a very good job of making my units exactly. But yeah, that looks pretty close, right? For my midpoint. So this half and that half would be the same. Okay. What should be true about the slope from M to S and the slope from R to M? They should be the same, right? Shouldn't they be the same rise over run? Okay. Anything on the line would have the same. All right, so we're going to do some practice problems. So grab yourself a practice space. Pause the formula, and you'll probably be happy after you see this that you do not need to memorize this. So you may memorize it. We will see. So I'm going to take a moment to copy it down, and then I'll talk about it after you copy it down. So if you remember our notation, whenever we have two letters next to each other with nothing above it, that means we're talking about the length between A and B or the distance between A and B. Okay, we're just using A and B as a generic two numbers, 2 points. It could be any letters. It could be point C to D, point E to F, whatever it is. We just use AB as our generic thing. Again, we should be familiar with seeing these subscripts because we just saw that with our midpoints. So as long as I am labeling my points with x sub 1, y sub 1, and x sub 2, y sub 2, all I have to do is plug them into the formula and then evaluate. So what we're doing is we're taking the difference now, as opposed to the sum, that's what we did in midpoint, of my two x's, and I'm squaring it. And I'm taking the difference of my y's and squaring it, and then I'm adding them together, and then I'm taking the square root. Okay? Now, I want your answers always in simplified radical form if they are not perfect squares. You'll notice up here for 31 through 33, these are your distance problems in your homework. Your textbook is going to say round to the nearest tenth. I do not want you rounding. I want your answers written in simplified radical form. Okay, so you got to make sure you're practicing that. All right, so for our first example, we're finding the length or the distance between point R and S when we have the following 2 points. So let's go ahead and label x sub 1, y sub 1, x sub 2, y sub 2. So now it's just a matter of plugging it into our formula. So instead of AB, I'm going to use RS. I'm going to put a giant square root sign. All right, so what comes first in our formula? X sub 2, which is which number? 4. So 4 minus x sub 1, which is 2. And then we square that result. And I'm going to add to it y sub 2, which is negative 1, minus y sub 1, which is 3, and squaring it. Common mistakes are going to occur, like over here when you're dealing with negatives. Adding and subtracting negatives is tough for us to do. So let's do the easy one first. 4 minus 2 is 2, so I'm going to bring down my square root sign. So now I have a 2, which is going to be squared. Negative 1 minus 3. Negative 4, which I'm going to end up squaring. Why was it important that I put that negative 4 in parentheses? Cody? Because it has a negative, and then that's okay. So when I square it, what should happen? My result should be positive or negative? Positive. Anytime you square something, your result should be a positive, right? Okay, so 2 squared is 4. Negative 4 squared is 4 times 4, 16. 4 plus 16 is 20. I'm going to go up here so the people in the back of the room can see. So now we are left with RS is equal to the square root of 20. Can I simplify that? Yes. We just did it, I think. Does anybody remember what that simplified to? So 4, 5, 2, and 2. My pairing is of what numbers? 2. So my final answer is 2 square root 5. Okay. Distance formula. Questions with that? So it's just a matter of plugging it into your formula, and then the tricky part's going to be, can you simplify the radical? All right, so the next one has us plotting the points and doing a whole bunch of stuff, compiling it all together. Is everybody good? Can I erase this? Okay. So for our last example, we're going to have to use both midpoint and distance formula. So let's go ahead and plot point J. So go to the right 6, go down 2. So right 6 down 2, label that a J. M is at -2, 4, so go to the left 2, up 4 from the origin. Make that an M. As best as you can, try to make the straightest line. If you have just the side of a folder or something, you could use that for a straight edge, or maybe you're just really good at making straight lines. Try to make a straight line connecting M to J. All right. Now, calculate the midpoint of JM. So how do we do midpoint again? Midpoint is equal to, what do we do with my x's? Add them and divide by 2. So 6 plus -2 over 2. I'm going to do the same thing for my y's. -2 and 4. It's -2 plus 4 divided by 2. 6 plus -2 is 4. Divided by 2 is 2. -2 plus 4 is +2. Divided by 2 is 1. Okay, there's my midpoint. Plot it. Hopefully it's on your line, or close enough. Mine's pretty close. Is yours on your line? At 2, 1. Okay, so we found the midpoint. Now we need to calculate the length of JM, which means we need to use the distance formula. So JM with no symbol above is equal to the square root. What's my x sub 2? Which number? -2, good. Minus my x sub 1, which is 6 squared, plus my y sub 2, which is 4, minus my y sub 2, ooh, we gotta be careful here, minus a -2. And then we're gonna square that. So a -2 minus 6 would be -8. So I have a -8, which needs to be squared, plus 4 minus a -2. Keep, change, right? Minus a negative goes to a plus. So 4 plus 2, 6 squared. Okay. Does everybody have the midpoint part? Can I erase that? I know it's hard in the back of the room to see when I get low. Okay, so now we have JM is equal to, what's -8 squared? Positive 64, always positive. Plus 6 squared, which is 36. 64 plus 36, ooh, that's nice. Why is that nice? That's equals to 100. What's the square root of 100? That's perfect square, 10. So JM is equal to 10. Okay? So, distance formula. The trickiest part that I have students having issues with is when you have all these negatives in here and they mess up adding and subtracting negatives. A lot of times common mistakes are when they go to square a negative 8, they'll make this be a negative 64, which will make them have an error because then they're adding negative 64 plus 36, which would result in a negative, and you can't take the square root of a negative, so that should be a red flag. Okay? And then making sure you can simplify square roots. And then the only other hard part of your homework is going to be these 25 through 29 odds, which is where I give you an endpoint and the midpoint, find the other endpoint. If you do that graphically, try to get as organized as you can. All right, any questions about